So in the last video we derived the limit formula for differentiation, and we did that by looking specifically at the curve f of x equals x squared. However, if you think about it, that curve could have been anything. We just picked a random point on the curve, and we just made another point get closer and closer to that particular point by letting the distance between the points get closer and closer to zero. So actually, we could have really derived this formula for any curve whatsoever. So this formula to get the gradient function of a function works for anything at all. So it's very powerful. What it does is it helps us show that what the gradient function of a function is. So that's what we're going to do now. We're going to show that when f of x equals x squared, the gradient function f dash x is equal to 2x, and we can do that using this formula. So I've got f dash x is the limit as h tends to 0, and we need f of x plus h for this. So instead of x, I'm going to replace the input with x plus h. So that's going to give me x plus h all squared. F of x there is of course just x squared, and that's divided by h. Okay. I've got this here which I'm going to have to expand out, so I'll just do this on the side. So x plus h all squared is x squared plus 2hx plus h squared. Okay, if you write out the double brackets and expand it out, that's what you get. So now I'll use that in my formula. The limit as h tends to 0 of x squared plus 2hx plus h squared, and then this minus x squared divided by h. Well, if you look at the numerator of this fraction, the x squared and the minus x squared cancel out. Okay, so that leaves us with just 2hx plus h squared over h. Now, if you look at both parts of the numerator, they're both divisible by h. We can divide this by h, and we can divide this h squared by h just to get h by itself. So we're left with the limit as h tends to 0 of 2x plus h. And I'm just going to put brackets around that to show that. So at this point, now we can let h get closer and closer to 0, and we can imagine that it does actually equal 0. It never can, of course, because remember, if h equals 0, then that would be mathematically impossible because you can't divide by 0. But we can imagine that h is 0, or it gets really, really close to 0. And when h gets really, really close to 0, we're only going to be left with this part here, the 2x. The h is just going to become nothing. So we're left with f dash x, the gradient function, is equal to 2x. Okay, so that proves for us that when f of x is x squared, the gradient function is 2x. Hope that helps. Before I leave you, I will say that, as I said at the start of this video, you can prove the gradient function for any function. So for example, if I had the function, say, f of x equals sine x, and I wanted to prove that f dash x was cos x, because this is in fact the case, okay? Which I will do a video on shortly. But if I wanted to prove that, I could use this formula. However, it can get quite difficult with slightly more tricky functions. So with x squared, it wasn't too hard, it wasn't too difficult. Whereas with other functions, it can be very difficult. So we might have to use some different techniques to show that. Okay, we might not be able to prove it. But again, I hope that helps with this particular section of the course. Thanks a lot. Bye.